Yes, Nikhil sir, we can start.
Yes, sir. Yeah. Yeah, just a moment. I'm turning my camera on. So do you need to put start recording?
Uh, yes, sir.
I can put it right now. Okay. Yes, students. Yeah, is my screen visible?
Yes, sir.
Yeah. Okay. Yeah. Very good evening to all. Yeah. Hi. Welcome to iitians Gate classes. Yeah. So I get experience. I hope the preparation is going well regarding your gate exams. I think only few, now the countable days are left. So it's today is the 10th, and in the first week of February we'll be having the exams. So I hope preparation is going well. You're writing the mock test, revising the concepts and all. Yeah. So let's get started. So the plan for today's classes will be actually covering questions related to programming, data structures, and algorithm. Okay, so these questions will be actually given by has been asked in the sample question paper. So we'll be solving these questions today. Okay, yeah. So let's get started, students. So let's discuss the first question of the today's class. Yeah. So the worst case running time of insertion sort, merge sort, and quick sort respectively are. Come on. I know preparation is going well. Come on. Think about it, students. The worst case running time of insertion sort, merge sort, and quick sort are. Come on. Option C, insertion sort is order of n square, is saying. Merge sort is n log n. Okay. Quick sort is order of n square. Okay. Okay. Others, come on. Yes. Okay. So yes, the answer is worst case running time of insertion sort, merge sort, and quick sort are this. Very good. Insertion sort. Okay. So before coming to the precise option, let's discuss the scenarios in which the worst case of insertion sort will come. So what should be the worst case scenario of insertion sort, students? Like what should be the input such that insertion sort will give me the order of n square time? Come on. Think. We have discussed in the class. What should be the scenario for insertion sort to produce to give the worst case? Come on, think. Insertion sort worst case scenario. Come on. When can it happen? Yes, Aditya. Come on, students. I know you have revised. What is the worst case scenario of insertion sort? Yes, we know it's order of n square, but on what input case it will be order of n square? Yes, yes. Decreasing order when we would like to sort it in increasing order. Excellent, Aditya. So in this case, what will be happening? Say if we would like to sort, like this is the case, right? Like we would like to sort it in the ascending order. So this is our final output, but input provided if it would have been 5, 4, 3, 2, 1. If it this would have been the scenario, right? So what would have happened that in this case the it is a worst case scenario. Why it would have been worst case scenario? Because we have to go all the way up to, like, if I'm standing at the ith element, so I have to go all the way up to I minus 1 elements. Okay, I have to go all the I minus 1 elements. So every time it will be like how many comparisons will be happening. So for I element, I minus 1 comparisons will be happening. So it's like 1 plus 2 plus 3 plus 4 all the way up to n minus 1. Okay, so that will be sum of n minus 1 natural numbers. It will be n into n minus 1 by 2. So that's why the time complexity is order of n square. Yes, very good. So for the worst case. Okay, may I know for best case, what will be the time complexity for insertion sort? Come on, come on. For best case scenario, what is the time complexity for insertion sort? Come on, students, come on. For best case, what will be the time complexity? Yes, yes, very good. Linear time. What should be the input sequence? What should be the input sequence? Very good. See, the if we would like to sort it in the increasing order and elements are also in the increasing order, then that is the best case scenario for insertion sort. Okay, yes, come on. Merge sort. Very good. Okay, so now let's come to merge sort. Merge sort, we know for all the scenarios, like for best case, worst case, average case, the time complexity will be order of n log n. Okay, why that is to be happen? Because we divide the array into the two halves and then we will perform the merge operation. Okay, so how this used to happen? This is the case. See, if this used to be the recurrence relation. If I am having a merge sort, so how should do? Like we will divide the array into the two halves. So this, if this is the time taken for n elements to sort using merge sort, so what we do, we divide the array into the two halves. We do it recursively, plus we'll do the merge operation. Okay, merge operation takes order of n time. Okay, so this is the recurrence relations. If you would like to solve t into 2 n by 2 plus n. Okay, so if this is the case, come on guys, so this is, can I apply master theorem over here? Come on students, can I apply master theorem? Yes, master theorem can be applied. Come on, I want response. Master theorem, can it be applied? Yes, so this is a which case of master theorem? This is a which case of master theorem? Case 1, case 2, case 3? Come on, which case? This is, come on students, this is case 2. Okay, so in case 2 what happens? N power log a to the base b is same as this guy, order of n. Okay, so this is the case. So what happens that, again, what is a is here, what is b is base. So a is 2, b is 2, so n power like log 2 to the base 2. So this is n and then this is theta of n. So if you consider this as f of n and this guy, so they are following under theta. So this will be n, I'm sorry, yeah. So this guy will be n power log n power k. Sorry, k plus 1. What was k? K value was 0 in this case. So it will be n log n. Yes? Yeah, so that's why we say that for the worst case scenario, merge sort will be order of n log n. Okay, yes, come on, for quick sort, what will be the answer for quick sort? Come on students, for quick sort, what will be the answer? Like it is order of n square, we know, for the worst case. Okay, come on, so what is the input sequence in which we'll be getting order of n square? What is the input sequence for which we'll be getting order of n square? I'm asking what should be the input being given to the quicksort such that it behaves, it has its worst case scenario, and we know that time complexity is okay, order of n square. So what is the input sequence we should give? Come on, this can be the popular interview question after clearing gate and going to some institute for clearing the interviews for the research programs. Come on, quicksort, what is the worst case? See, at conceptual level, come on. See, quicksort taking the pivot element as the lowest number in the decreasing order. Hmm. Yes, pivot element scenarios, that is also happening. See, in quicksort, what happens is that how it works, it all happens with the pivot element scenario. Okay, we select the pivot element. Okay, come on, quicksort, how it works? Quicksort works on the pivot element basis. So we select a pivot element and we kept the position element in such a manner that all the elements which are to the left of the pivot element are being kept here, and all the elements which are to the right of the pivot element, they are kept over here. Okay, then we apply quicksort on this part, then we apply quicksort on this side. Okay, so this how it used to happen. So what happens that for quicksort, what should be the input sequence, such that if we are getting the worst case scenario of order of n square is if the input is already sorted. Okay, if the input is already sorted, that is the worst case scenario of quick sort. Okay, we'll all remember. Yes. Why? Because in this case, like if the typical tradition is like if we are selecting always the like lower element position as a pivot element, then it won't divide the array into the equal halves. Okay, so every time there will be too many comparisons happening. So in this case, what will be the recurrence relation? What will be the recurrence relation, students? Come on, what will be the recurrence relation? T of n equal to T of n minus 1 plus n. So if we will solve this recurrence relation, what will be getting the answer? Come on, students, come on. For the quicksort scenario, if we are getting this recurrence relation, so what will be the time complexity? No, 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 no. Come on, come on. Okay, first of all, is this the correct relation of quicksort? Or I should have written T of n as T of n minus 1 plus 1. Come on, students. I should have written this guy, or is this relation? Come on, which is correct? Which is correct? Come on, come on. Which is correct? Is this one or this one? This is first and this is second. For the worst case scenario, is this is the correct one or this is the correct one? Come on, students, come on, come on. Okay, no problem. Think about it. I'll give the answer to this thing at the end of the class. Okay, come on, come on. Think. Yeah. So for the worst case scenario for the quicksort, this is the correct option. Okay, C is correct. Very good, Aditya. Yes, you got it correct. Okay. Yes. You have something to say for this reconciliation for quicksort worst case scenario, which is correct? First or second? Come on, students, come on. No problem. Think about it. Okay. Very good. Yeah, first is correct. If you'll solve this equation, it will be order of n square. Okay. Yeah. So just solve it and you'll get the answer. Okay. No problem. Yeah. Come on. Second question. Let's try to solve second reconciliation question. So the running time of the above function is, come on, take a moment, don't be in hurry. Think this is a gate question. Okay, you are solving this question in the gate hall, in the gate exam hall. Okay, any negative like answer, like incorrect answer, will give you -1/3 or -2/3. Okay, so, or if you're not confident, don't select the option. Come on, I hope you solve the question in that manner only. Okay, when we are giving the mock test. Chalo. In gate exam, it's very important that we are solving the questions like more accurately. Okay, instead of just giving blindly answers. Okay, D option. Let's discuss how we got D option. Let's see. Let's try to. So can I apply master theorem over here, students? Can I apply master theorem? So what is the general recurrence relation they are saying? T of n is equals to 3 times of T of n minus 3 minus, come on, T of n minus 2. Can I say this? Can I say this? Yes, very good. Okay, so now let's, I can't apply master theorem over here. I hope it's very clear, because in this case, what will be happening is that this is not in the form of E into C to apply master theorem. This has to be in this form, E into f of n by b. Sorry, t into plus theta of f of n. It should be in this form. So it is not in this form. So we cannot apply master theorem over here. So what we'll do, it will be like T of n is equals to, like this is the recurrence relation we are having, T of n minus 3 minus t of n minus 2. Okay, now let's try to draw the recurrence relation over here plus some constant. Okay, yeah. So if we try to draw this recurrence relation, so how it will be happening, t of n is, let's say this is n. So I can say this is n minus 3, this is n minus 2. Okay, yes, yes, it's n minus 3 and n minus 2. Okay, so similarly now can I say n minus 3 will be as good as writing n minus 6, n minus 5. Similarly n minus 2, can I write it as n minus 5, n minus 4? Can I write it? Yes. So guys, if I'm trying to draw like tree like this, we are trying to solve this question with the help of recurrence tree. Okay, we are trying to solve this question with the help of recurrence tree. Now the question is, what will be the height of the tree in this case? Come on, what will be the height of tree? Come on students, what will be the height of tree in this case? Think. See, I am here n, then n minus 2, then n minus 4, then n minus 6, then n minus 8. So come on, think. I know you know the answer. Come on, what will be the height of the tree in this case? At every level, what is, how many, like, if I'm having n, so at next level, what is the value? It is n minus 2, then n minus 4. So at each level, we are decrementing by 2. Do you agree? Do you agree, students? At each level, we are decrementing it by 2. Come on, students. Your response means a lot to me. Is it clear? Is it clear? Is it clear, students? Okay. So, see, so this is n, then at n minus 2, n minus 4, n minus 6, n minus 8. So can I say, students, that the height of the tree will be n by 2? Why? Because every time we are decrementing it by 2. So assume that n value would have been 6. So what would have happened? 6, then 4, then 2, then 1. So approximately, can you see that the height of the tree is getting as n by 2, assuming root is at level 0. So maximum level will be what? N by 2. Okay, n by 2 will be happening. Okay, now please all eyes on the screen. If I'm having height of the tree as n by 2, if I'm having height of the tree as n by 2, what is the maximum number of nodes possible? Come on, if I'm saying the height of the tree is h, please all eyes on the screen. This is very important. This can be a probable gate question. If the height of the tree, if the height of the tree is h, what is the maximum number of nodes possible in binary tree? Come on, if the height of, I should say here like this, if the height of binary tree is h, what is the maximum number of nodes possible? Come on, what is the maximum number of nodes possible? Think. If h is 2, if h is 2, what is the maximum number of nodes? Assuming root is at a tree with only root is at height 0. So see, if I'm having h as 1, so how many nodes? Come on, maximum 2 power h plus 1. Can I say this? See, if height is 2, how many nodes? 7. So can I say 2 power h plus 1 minus 1? Come on, students, come on. Can I say this? So what I want to say, the maximum number of nodes will be order of 2 power h. Yes? Do you agree? Do you agree? So in this case, what will be happening, that the height of the tree is 2 power like n by 2. So what will be the maximum number of nodes? 2 power n by 2. Okay. So that's why the time complexity for this relation is order of 2 power n. I hope it's very clear. Why? Because the height of the tree was n by 2. Okay. So the maximum number of nodes possible will be 2 power h. So 2 power n by 2. So 2 power n by 2 into constant. So that's why the option is correct. Okay. Yes. Yeah. Okay, let's go to another question. Come on, this is very trivial, I would say. This they have given is question related to binary search. Come on, what can be the answer? Which one of the following equations correctly describes the recurrence relation for standard binary search on a sorted array of n numbers where c is a constant? How binary search works? Come on, come on. How binary search works? See, let's try to write the algorithm for binary search. See, this is binary search, okay? So here what will be happening? We'll be having low element, we will be having high element, then let's say we are having array, then we are having target element. Okay, now what will be happening is the following. Okay, so what we'll do, while low is less than equal to high, okay, yes, if greater than, yeah, let's see, no problem. See, yeah, so we'll do this. While low is less than equals to high, so integer mid is equals to, what we do low plus high by 2. Okay, now we check if array of mid is equals to key, what we return mid. Okay, now if the element, okay, if the element, if it is smaller, if the element is smaller than the middle element, like if the element that we are looking for is smaller, so what we have to do, come on, is it, like, fill in the blanks, I would say. What I should write, come on, I would like to hear from you guys. What I should write over here? If this is A and then this is B, come on, what is A and what is B? Think, students, think. It should be on your fingertips. Binary search. Come on. So if the element that we are looking for is smaller than the middle element, so what I should update? So we have two options I'm giving. Low is equals to mid plus 1. Okay. High is equals to mid minus 1. Yes. Okay. Come on. So let's say if this is number 1 and this is number 2. So A should be put at 1 or 2, or 1 should be put at A or B. Come on. Come on, I made your job easier. Come on, come on. Low is equals to mid plus 1 or high equal to mid minus 1. Where I should put this? Think. Yes, come on. It could be a probable gate question. A is mid minus 1. B is mid minus 1. Come on. Mid plus 1 what? What is your assignment? To whom mid plus 1 or to whom mid minus 1 you are assigning? That's the question. See, A is a fill in the blank, B is also fill in the blank, and I'm giving you two options like 1 and 2. Okay, so I'm asking the statement number 1 should be mapped to which fill in the blank, A or B? Okay, that is the question. Come on, students, come on. If key is smaller than array of mid, then what I should say? Then I have to search in the left part of the array. So high is equals to mid minus 1. Okay, otherwise it's in the right part of the array. So low is equals to mid plus 1. Yes? Yes, do you agree, students? Yes, so that's what I was listening for. Okay. Come on, students. I'm emphasizing on my past experience. Binary search, it's very, I would say, it's quite simple, and it should be on our fingertips. And there is high chance that in the interviews they will ask some questions related to that. Okay. So if we are eligible, so not only in the interviews of the like for the higher studies, even if you go for camp like jobs and all, so they will ask questions on binary search also. So come on, okay, yeah, it should be there. Now come on, recurrence relation. Students, you like to change the answer? I got B as one response. C, always binary search, what will happen? That you will compare the middle element. So this comparison will take some time. Do you agree with me? Do you agree with me, students, that this comparison will take some time? So let's assume that this is C is a constant that time will be taking. So first you do check, okay, if this is this part, like if it is the if the element is equal, so that is constant time will be taking, then we'll be taking either the left or the right, but we won't be taking the both. So we have divided that into two halves, so that's why this is the time complexity. Okay, so t of n equal to t of n by 2 plus constant time. Okay, so that's why D is the correct option. Okay, students, please think that why we given B option earlier. Okay, sometimes the questions will be very simple in gate. We have to be using our presence of mind. Okay, see, beautifully they have given B option first and then the correct option later. Students might not check all the options and they will give incorrect answer. Okay, so that's why it's important to be focused on this. Yes. Yes, students. So one question related to Python programming. Okay, I hope we are aware of little bit Python. Yes. So let Z be an array of 10 elements with Z of I equal to 2. So the value returned by the function Z10 comma 2 is. Come on, let's try. Let's try. Today, do you want to check the Python skills? Assume you have this much time left in the gate exam, the duration wise, I'm saying like 3 hours in you're sitting in the exam hall and 3 minutes is being left close to, and let's say this is the last question is pending. So from thinking that perspective, let's try to solve. Okay, come on, let's try. Okay, AGP series. Come on, so what is the answer? Are you sure? Are you sure? Come on. You have 1 minute left. Come on, students, to everyone. So, what is the final number? The value is? Okay. So let's discuss, students. So even if someone doesn't got what like AGP things and all, so let's discuss, students. So value returned by the above function is, so what is the value of n value is 10 and m value is 2. Okay, sorry, m value is 2, yes, n value is 10, and all the elements is being initialized to 10, means I am having an array of 10 elements and all the elements is being initialized with 2. Okay, yes, yeah. So let's discuss, like for who didn't got it. So let's say if n is equals to 10, so this is initialized. So what is happening? M is equals to m into s plus a of I. So initially s, what is the value s is storing? S is storing 2. What is the value of m? Initially m is having the value as 2. Okay, so initially what is happening? M is equals to m into s. So for the first iteration, so how many times this loop will be executing? Come on, students, how many times this loop will be executing? 9, 10, 8. How many times? How many times this loop will be executing? Very good. It will be executed 9 times. Okay. So how this will be happening? How this will be happening is the following. So we'll be having 1 to n minus 1. Okay. So now how it will be happening is the following, that initially m value will be 2. So 2 into s. So s value is 2. So initially 2 into 2, 4. 4. Initially m value is s, m value is 2, s value is 2, and then a of I. Okay, a of I, every element is 2, so every time this 2 will be added. So for the first iteration, value will be 2 into 2, 4, 4 plus 2. Okay, so this is 6. So in the next time, so what will be happening, that m value is initialized with 6. Okay, very good, yes. So for the, yeah, so for the next time what will be happening, again 6 I'll be having, so 6 into 2, so 12 plus 2. So can I say next time 14 will be there? Yeah, so next time again 14 into 2 plus 2. Okay, so 14 into 28, 28 plus 2, 30. Okay, so are you getting some pattern? So whatever the previous element, multiplied by 2 and then add 2. Okay, so 30 into 2, 60, and then 62. Again 62 you will double, so it will be 124, then plus 2, 126. Yes, 126 you will double, it will be 252. Yes, come on, students. So like this is the first iteration, third, fourth, fifth. Similarly, if you will follow, you get the answer as 2046. Okay, it's all like you double and then add 2, then add 2. Okay, so yeah, that is the case. Okay, yes, any doubts, students? Any doubts? Come on, your response means a lot to me. Any doubts? Yes, Aditya, you have something to say? I didn't got you. 16 into 2, 32, 32 into 2, 6. No, no, there's a plus 2 also, right? Okay, okay, okay. In that manner, you're saying, yeah, yeah, yeah. But we can't do always. See, if S value would have been, let's say 3 or 4. So in that case, what would have happened? right? So we have to check those perspective also. So like base always. So we have to keep checking. If it sounds fine, then we can add. Okay. Yeah. Yeah, 2046 is correct. Okay. Chalo. Next question again is a Python based programming. Yes. So what is the answer? Come on, students. What is the answer? Please again assume options are not given. Okay, in the gate it will be like NAT, numerical answer type question. So please try to solve this question as if it is NAT 2 mark question. Okay, come on. I think I should give 1 minute on this. Okay, 40 seconds extra. Come on, try. One last 20 seconds. Okay. Yeah. Let's see. Let's see, guys. Yeah. Sure. So what is the value of I? Let's say we are drawing a big box for I. Okay, J. So when this loop will break, when J mod 3 is equals to 0. So I is initially 1, J is initially 1. Okay, yes, please all eyes on the screen. Yeah, for I in the range 1 to 11. Okay, so this is for loop. So nothing is being else. So it will be automatically increment by 1. Okay, so yeah, so let's discuss one by one. So what will be happening? Okay, so we are getting I is 6, J is 9. Okay, let's discuss. So I1 is 1 mod 3 equal to 0. No, so yeah, so this block will be get executed. So 1 J will be updated to 3. Okay, now continue. So this block won't be getting executed. Okay, so again will be here. I value will be 2. Is 2 mod 3 equal to 0? No. Again J plus 2. So 3 will be updated to 5. Okay, again continue. Now I value will be 3. So now 3 mod 3 is equal to 0. Yes, so this block won't get executed. We'll check. Is J mod 3 equal to 0? No. J value is 5. Okay, so again we'll continue. So now I value will be 4. Okay, 4 mod 3. No. Again, so 5 will be updated to 7. Okay, continue again. I value will be 5. Yes. 5 mod 3 equal to 0. No. Again, now it will be 9. Now again I will be updated to 6. So 6 mod 3 equal to 0. Yes. So now we'll check here. Is j mod 3 equal to 0? Yes. So 9 mod 3 is equal to 0. So break. So I is 6, j is 9. So 6 plus 9, 15. So yes, D is correct. Okay. Yes, good. Yeah. Okay, come on. Let's read this part of the question first. We read this now. Okay. So now the context is that we have to A, B, C, D with the like NQ or DQ. Okay. So this is a question. So now being read this part of the question, so which of the following options for the functions A, B, C, D correspond to the correct implementation for the push and pop operation on the stack? So if you guys remember, so we have to implement stack using queues. Okay. So this question boils down to implement stack using queues. This is a question. So now how we'll be doing? So yes, what should be A, B, C, D? Okay. Just map what should be A, what should be B, C, D in terms of NQ and DQ. We all know, I think NQ means insertion of the element onto the queue. Okay, DQ means removing the element from the queue. Yes? Yeah. Okay, AB is NQ, CD is DQ. Okay, okay. Okay. Say so now what is happening is the following. So we all remember, we all know in queue insertion happens at one end and deletion happens at the other end. Okay, but in stack what happens? Insertion and deletion happens from the same end. So in stack what happens is the element which was inserted last is the first one to remove out. Okay, but in queue we follow FIFO order, like first in first out, like that. Okay. So now so how, what does this algorithm says? Let's discuss. Let's traverse this algorithm, students. Please all eyes on the screen. So what is happening that push s comma x. Okay. So again, so okay. So may I know one question? I want to ask one question. So push operation is like inserting the element onto the stack. So what is the time complexity of pushing the element onto the stack? Like with this NQ operation with the help of Q? Assuming at this moment I am having n elements into the stack. Okay, n elements onto stack. Okay, now the question is the following. I am having n elements on the stack. Now I would like to perform push operation. So what is the time complexity? Very good. It will be order of n. Okay, so let's see students how these things are happening. say I would like to insert push operation onto the stack. Say I'm inserting element 1. So what is happening? So again, as you all remember that we can implement stack using queues, and number of queues required is 2. So here also they are using two queues, q1 and q2. Okay, so now how these things are happening? How these things are happening, please all eyes on the screen, students. So first we are doing a of q2 comma x. So yes, you are correct, students. A will be nq, b will be nq, c will be dq, and d will be also dq. Okay, yes. So what is happening is the following, that I would like to insert an element onto the stack s comma x. Okay, so now what I am inserting, first I am inserting onto the q2. So let's say there are two queues. Okay, initially both will be empty. Do you all agree? Initially both the queues will be empty because there is no element on the stack only. So let's say I would like to perform queue operation. So we are discussing that how this happening is happening. So is this is nq operation. Okay, so what we are doing, I'm inserting the element onto the queue. So that element 1 I have inserted over here. Now what is happening? While q1 is not empty, is q1 empty? Yes, so this block won't be getting executed. So now what will be happening? Swap q1 comma q2. So this guy will be q1 and then this guy will be q2. Till here it is clear? Yes. Now let's say, so now initially how should my stack looks? Like let's assume that this is stack, like 1 has been inserted. Okay, now I would like to insert 2. Ideally how I should feel, that if 2 got inserted, so what will be happening, that 2 got inserted, so when I should perform pop operation, 2 should be removed. Okay, so let's see this algorithm. So what they're saying, first insert the element into the queue, q2 queue. So 2 will be inserted over here. So now what is happening, while q1 is not empty, so c is the dq operation. Okay, c is dec. Okay, so yes, it's a dec operation, and similarly this is also dq operation. So what they're saying, remove the element from q1 and insert it onto the q2. Okay, so 2 will be here and then 1 will be coming here. Okay, so now I removed it, so now this queue is empty. Okay, so now again what they are saying, swap q1 and q2. So yeah, so how this will be happening, now this is my q1 and this is my q2. So So this is my q2 and this is empty. Okay, yes. So now I would like to insert element. So now let's say if I would like to perform pop operation, so what pop will be doing, return d of q1. So can I say when I'm doing pop operation, so how it is happening, I'm getting 2. Okay, happy. So yeah, so in the stack I would like to do pop operation, so 2 would have got removed. So here also pop, when I'm doing, so pop from q1, so that's why it's working. So we'll do one last thing. So let's say if we would like to insert 3, so how it will be happening, insert it onto the q2. So I've inserted 3 over here. Now while q1 is not empty, what we'll do, we'll do the dq. So let's say this is a front pointer and this is rear pointer. So what will be happening, 2 will be inserted to here. Okay, then 1 will be inserted to here. Okay, yes. So it will be 3, then 2, then 1. Yes, so 3 2 1 will be here. Please all eyes on the screen. So now once we have done this, now we'll do swap. So swap will be coming over here. So this is q1, sorry, this will be q1 and then this will be q2 and all the elements would have been removed. Yes, is it clear, students? Is it clear? Please ask me if you have any doubts. Okay, so now again if I do the pop operation, so on top, like the stack is having 3, so here also 3 will get removed. Okay, then you would like to do remove, so 2 will get removed, then you will do pop operation, then you will do 1, so like that. Okay, is it clear, students, how this algorithm is working? Yes, you got the correct answer, but we should also know how these things work. Okay, now I would like to do a small modification over here. Please always on the screen. Okay, so let's say we would like to implement queue using stack. Queue using stack. Okay, how we will do this can be probable interview question. Come on. How we will implement queue using stack? Come on, students, think. Think. So assume I'm having two stacks, S1 and S2. Okay, so now Q follows FIFO operations. The element which was inserted first is the first one to remove. Okay, but stack follows last and first out. So how will be implementing? Yes, yes. So let's discuss, students. Let's discuss. Okay, I'm having element 1, then I'm having element 2, and I'm having element 3, 4, like this. Okay, so let's say I would like to insert 1. So let's say 1 will be inserted over here. Okay, now 2 comes. So now 2 comes, what we'll be doing? We'll be, let's say, inserting it here only. Okay, now say pop operation. And now let's say in I've inserted 1 2. Okay, I inserted 1 2. So let's say my rear pointer is here. Assuming that there is no like there is no 3 4 has come, but I like DQ operation. Okay, so ideally according to Q, I am having two elements, 1 and 2. Okay, so now which element should get removed? 1. Okay, but in the stack currently what is happening? This is happening. Okay, so what we'll do, we'll push the elements over here. So 1 2 will be like, first 2 will be here, and then this one will be here. Okay, so initially like this guy will get removed. Okay, so dedicate one stack for the pop operation. So now, if I would like to perform pop operation, so what will be happening? Yes, one will get removed. So yes, it's performing correctly. Now, this gets removed. Okay, so now let's say I would like to insert 3. Okay, I would like to insert 3. So what is my queue status? Like it is 2, then 3 will have inserted. So now it will be inserted in S1. Okay, so 3 will have inserted over here. Okay, now I would like to insert, let's say, 4. Okay, so this would have come. So now what will be happening? Now it's now we would like to do pop operation. So okay, this is my queue status. So this is front and this is rear. Okay, so now ideally according to queue, like if I'd like to perform deck operation, so which element should get removed? Come on, which element should get removed? 2. Okay, so now we'll check, like S2 stack is dedicated for pop operation. Okay, and S1 is dedicated for push operation. You can like dedicated for DQ. Okay, and this guy is for NQ. Okay, yes. Now please always on the screen. So what will be happening is that we are here at 2. Okay, so now we all know that if I like to perform deck operation, so 2 should get removed. So we check that if my S2 stack is empty, no, like so, just pop it and get the answer. So 2 will get removed over here. Okay, then 2 is the answer. Okay, now if I would like to perform pop operations, so I'll check, is my S2 empty? Yes, my S2 stack is empty. So transfer all the elements over here. So 4 will be coming here, and then 3 will be coming here, and then you pop the topmost element. Okay, so in this case, I'll get 3 as the answer. So 2 is removed, 3 is removed. Okay, so now this way it is happening. Okay, is it clear, students, how we can implement queue using stack? I know it's not been asked in the question, but if they have given stack using queue, so they can also ask queue using stack. Okay, so this was the intent. Is it clear, Aditya and others? Yeah, okay, thank you for the response. Yeah. Yes. So this is another Python programming related question. Okay. So the context is that what, first read the question, then I will say. So this is my array. say then this is some array, and let's say d value is always 4. Okay, d value is being given. Okay, so now for what values, like for what arrays this function should return 1. Okay, so these are the options, like these are the various inputs being given. So for pqrs, which options, like for which options the function should return 1 as an output. Okay, this is the question. So as you can see, A is always being given array as this. For your simplicity, I'll write the B arrays. Okay, sorry. So for first scenarios, B is 3, 4, 5, 6. Okay, A is always fixed. So again, 2, 4, 6, 8. And the last one is, I think, 1.1, 2.1, 3.1, 4.1. Okay. Yes. So A is array is fixed, students. So let's say this is P, this is Q, this is R, and then this is S. So for which of the followings, like this function will return 1? This is the question. Okay, come on, try. So A and B. First you take this, then you take this, then this, then this. Okay, come on, try. Why P? Acha, just curious, guys. Let's say in Python, say if I'm giving 1 by 3.0. Okay, what is the answer? Is it 0? Very good. We all know, right? Very good. Yes. Okay. So what is happening? Can I say what is the value of n1? What is the value of n1 over here? Come on, guys. What is the value of n1? Can I say like it's a sum of the squares of the elements which is being present in the array? Very good. Okay. So can I say n1 value is what? 1 square plus 2 square plus 3 square plus 4 square. So it is, can I say 16, 9, 25, 25, 26, 30. Okay, so n1 is 30. Okay, similarly n2 will depend upon my array. Okay, yes. No, why n1 is 5? N1 is never 5. Okay, it's always ai into ai. Like 1 into 1, then 2 into 2, then 3 into 3 plus 4 into 4. Is it clear? Come on, response. No. But here n1 is not getting updated, right? Is n1 getting updated? That is a square root of n1. Okay. See, math dot square root of n1. Does it mean I'm updating n1? No, it's just that what is the value present at n1? I'm computing the square root. Okay, yes. So math dot square root of n1, that will be 5.5, but it doesn't mean n1 value is getting changed. Okay, yes. Similarly, n2 will compute sum of squares. So we'll compute a of I, then we'll compute b of I. Okay. So now for I in the range D, if a of I is not equal to b of I, flag equal to 0. Can I say for first element only, a of I won't be equal to b of I? Come on, come on. What will be the value for this case? It will be 1 by 5 point something. Okay. So in this case, for other case, what will be happening? It will be 3 by, what is the sum of square? Like 6 square, 36, 36, 25, 16, and then 9. So 9 plus 16, 25, 25, 25, 50, 50, 36, 86. So 3 by square root of 86. Okay. Yes. So they are different, right? Do you agree? They are different. So can I say it will be equal to 0 and then break, and then this guy will be returning 0? Do we all agree? So that's why P won't be the answer. What is there? That for which of the following algorithm will produce 1 as an output? Okay. Do you agree, Aditya? That P won't be the answer. Yes? Yeah. Come on, let's try for Q. Let's try for Q. Very good. Why? Because it's proportionate over here. Okay. So it will be like 1 square plus 2 square plus 3 square plus 4 square. B array will be what? B array will be what? It's like 2 square plus 4 square plus 6 square plus 8 square. Okay. So if I'll take 2 square common, so it will be like 1 square plus 2 square plus 3 square plus 4 square. Okay. So now if I'll take the square root, right? So I'll take 2 common over here. Okay. So 2 square root, you will take 2 outside, it will be present. Okay. Yeah. So 1 square, 2 square, 3 square, 4 square. Okay. So when you will compute, so again, the array elements above it's like twice. So when you do this, it will be like 2 times of 1, 2, 3, 4. So 2, 2 will get gone. So it will be proportionate. Okay. I hope it's very clear. Then for each of element, it will be like 1 by 1 square, 2 square. Then it will be like 2 by square root of this. Then it will be like 3 by square root of this. Then it will be like 4 by square root of this. Okay. So that's why in this case, they are proportionate. Come on. Can we say about R? Can we say about R anything? Is R also proportionate? So if it is proportionate, then we can say that it will be common. Yes. So Q and R also will be there. Okay. Very good. How about S? Students think, is R proportionate? Just ask yourself, is R proportionate? Like, say 1, I would like to multiply with 1.1. So how I should multiply 1.1? So like 2 into 1.1. Will it give me 2.1? Just ask yourself. Is it like 2 into 1.1? Will it give me 2.1? No, they will be 2.2. So they are not proportionate. So that's why A of I by this guy, right? So like N1 will be different and N2 will be different, and they won't be proportionate. So there will be a scenario when A of I is not equal to B of I. Okay, so in this case, what will be happening? We'll be returning this will return 0. So the correct answer is UNR. Okay, so C option is correct. Okay, yes, good. Yeah, one last question for today and then we'll conclude. Come on. Consider the following undirected graph on 5 nodes. Assuming you are performing BFS on this graph using Q, how many breadth first ordering are there? So this Q data structure is anyways redundant, because when BFS is there, so definitely we'll say that we are using Qs. Okay, yes. So how many unique BFS are possible? 120. Okay. How? 5 factorial. How? Okay. Let's discuss, students. Let's discuss, no problem. A, B, C, D, E. How breadth first search works? See, if I am starting from A, okay, what are the options I have? If I'm starting my BFS from A node, can I visit all any other nodes? B, E, D, C? Yes, very good. I can go from A, after A, E only. Okay, after E, how many options I have? 3 options, right? Do you all agree? I can go to either B, immediately I'm saying after E, I can go to immediately B, or maybe C, or maybe D. Okay, yes. But after A, when I went to A, can I go to B immediately after A? Can I go to immediately to B? In this case, I can't, right? Because it has to be like breadth first is how it works. You select a node, then you go to all its adjacent nodes one by one, then you will go to neighbors, like that it will happening. Okay, so yeah, that is the case. So now let's discuss about the ordering, guys. So if I am at A, I have to go to E, then I can have how many options? Like now any order will work, right? B, C, D, any order will work. So what are the options I have? 3 factorial. Do you agree? Very good. Yes. So AE, then 3 factorial. Okay. Now if I'm starting from B, then E. Okay. So how many options I'm having? Same for BCD. Very good. So it will be like 3 factorial. So can I say wherever the outer nodes are, it will be like 3 factorial for each of this into 4. Like for A we saw 3 factorial, similarly for B 3 factorial, C 3 factorial, D factorial. Okay, so this is for the outside nodes. Now let's start. Now can I start with the E node? I can also start with E node. Okay, so if I'm starting with E node, so how many options I am having? Come on, this we should get it correct. If I am at E node, so how many possibilities? Very good. So it will be like 4 factorial. Okay, so for this case, so 3 factorial into 4 is same as 4 factorial. So 4 factorial plus 4 factorial. Then you got the answer. It's 48. Okay. Please be accurate, students. Okay. So yeah. So yeah, thank you for attending the class. I hope the class was fruitful and we solved good amount of questions and we did good revision among the data structures, algorithms, and programming. Okay, so requesting you to revise as much as possible. And yeah, if you have any doubts, or can always reach out to us. And yeah, thank you for the attending the lecture. Yeah, so thank you. Bye bye, and all the best for the GATE exam. Keep preparing. Yeah, bye.